We'll be looking at Arrhenius theory of acid and base first. Then we'll look at Bronsted-Lowry theory of acid and base. Now, when we talk about an acid, first of all, acid and base is a measure of the hydrogen or hydroxide ion concentration. And different theories propose different definitions of acid and base. First, let's look at Arrhenius theory of acid and base. Now, Arrhenius defined an acid as any substance that when dissolved in water produces what? Hydrogen ion. So Arrhenius acid is any substance that when you dissolve it in water, it will produce what? Hydrogen ion in solution. So it means if this substance I have here, if I put it in water and hydrogen ion is produced, this substance is Arrhenius what? Acid. Now Arrhenius defined a base as any substance that when dissolved in water produces what? Hydroxide ion. That's OH minus ion as the only negative ion. Now, that being the case, Arrhenius acid, this is hydrochloric acid, right? If I dissolve this in water, you agree with me that hydrochloric acid, if I dissolve it in water, I'll be having what? What will I be having? What will I be having? What of the oxygen? We will be having what? H3O plus what? Cl minus, is it not? I know this is equivalent to hydrogen ion, right? But let's forget about this. Just note that Arrhenius acid, any substance that if you dissolve in water, it will produce hydrogen ion as the only positive ion, right? Like this. That's my duster. Okay. If I dissolve this in water, it will dissociate to form hydrogen ion and chloride ion, right? This is the only positive ion here. This is Arrhenius acid. Water, if water dissociates, if H2O dissociates, we have what? H plus what? Right? HCN, hydrogen cyanide. If it dissolves, we still have hydrogen ion, right? This will have hydrogen ion. This will also have hydrogen ion. So any substance that dissolves in water to produce hydrogen ion is what? Arrhenius acid. So one condition for Arrhenius acid is water must be present, right? Because you are dissolving the substance in water, is it not? Good. Aqueous substance. Now, base, Arrhenius base produces hydroxide ion, right? Sodium hydroxide, if you dissolve it, you see it will ionize to what? Sodium ion and what? Hydroxide ion. Is it not? Also water. As you can see, water is both Arrhenius acid and Arrhenius base, right? Why? If I ionize this, I'll be having hydrogen ion and what? Hydroxide ion. And remember, Arrhenius acid, any substance that when dissolved in water or in solution, will give out hydrogen ion, right? So this is Arrhenius acid. It fulfills that condition. Arrhenius base, any substance that when dissolved in water or aqueous solution, will give out what? Hydroxide ion. So water is both Arrhenius acid and Arrhenius base, right? Any substance that can exist as an acid and a base is called what? Amphoteric substance, right? Good. Now, potassium hydroxide, magnesium hydroxide, they are all Arrhenius bases. Do we understand that? Good. Now, we have another theory of acids and base. Now, the next theory of acid and base is the Bronsted-Lowry theory. Bronsted-Lowry theory of acid and base. The Bronsted-Lowry theory of acid states that an acid is any substance that does what? That can donate what? Protons, right? Hydrogen ion, can give out hydrogen ion. Yeah, water is not a necessary condition. Dissolution in water is not the necessary condition to identify Bronsted-Lowry theory acids. But in Arrhenius, water must be present, right? Aqueous substance. Good. So Bronsted-Lowry theory acid, any substance that if you dissolve, that any substance that can ionize to give out proton. You know, hydrogen ion is a proton, right? Do you know why hydrogen ion is proton? Do you know why? Okay, just hydrogen. What's the atomic number of hydrogen? 1, right? And you agree with me that for every neutral atom, the number of proton and electron remains the same, right? The number of electron and proton for neutral atoms remains the same. So hydrogen has 1 proton, right? Proton is found in the nucleus. And it has 1 electron, is it not? But if this electron is given off, you add plus, because hydrogen have done one good thing, giving out 1. If it receives, minus. Collecting is bad now, minus. But if you give plus, so putting plus here, it means hydrogen has given out 1 electron, right? The only electron that hydrogen has. This was the person the Bible talked about that gave out the only thing she has. Sorry, he had. Girls receive, boys give. Alright, so hydrogen has given out the only electron. So there is no electron again, right? We are left with proton. That is why we said hydrogen ion is also proton. Now, any substance that can donate proton, that can donate hydrogen ion, is called what? Bronsted-Lowry what? Acid. While anyone that can accept proton is what? Bronsted-Lowry base. So if you look at it this way, base, Bronsted-Lowry base, we are not saying anyone that can produce OH. Anyone that can accept OH is Bronsted-Lowry what? Base.